Let's review together the cotangent function. The cotangent function is nothing else than the reciprocal of the tangent function. Cotangent of any angle t is equal to 1 over tangent of t. So the first thing that we want to focus on is that the cotangent function has a denominator, and the denominator should never be equal to 0. So what we need to see is where in the unit circle the sine of t becomes 0. The sine of t becomes 0 at 2 points. At the point 0, when the angle is equal to 0, and when the angle is equal to p. What does this mean? This means that since the sine of t should not be equal to 0, then this means that the angle t should not be equal to pi, 0 first of all, pi, 2 pi, 3 pi, and so on. So these are angle measures, points on the t-axis that they should not be included in the domain. So going up on our graph, we identify those points, this one, this one, this one. All multiples of pi, basically, should be excluded from the domain. As we know from the rational functions, this simply means that through those points we have vertical asymptotes. So we have infinite vertical asymptotes at all these points. Let's graph them so we see exactly how we split now the Cartesian plane. First of all, the y-axis is going to be a vertical asymptote. Also the pi, x equals to pi, will be a vertical asymptote. Also the 2 pi, right here, we are going to have a vertical asymptote. Remember that the cotangent as the tangent, both of them, they are repeating functions, they are periodical functions, so they repeat themselves within specific periods. The period for the cotangent, exactly as for the tangent, is nothing else than pi. So, when we move from here to here, the cotangent is going to take a full range of numbers as solution. So the cotangent for the x going from here, from the negative infinity to the positive infinity, is going to take a full range of functions. The period for the cotangent is pi. Okay, good. This is what we know. We know that, we know the vertical asymptotes, and now what I want you to focus at is this point right here. So when the t is equal to pi, before the t becomes pi, we are right here. The angles exactly before the p becomes pi gives us cosine, that is negative, and sine, that is positive. So the cotangent is going to be negative for points that are before pi, but then the cosine still is negative, but the sine also becomes negative. So what happens basically is that at pi, the cotangent is going to change sign, and from negative will become positive. So the sign for the cotangent, it's going to be negative for angles that they are smaller than pi, and positive for angles that are larger than pi. And it's going to be equal to 0. The cotangent will be equal to 0 when the cosine of t is 0. Now the cosine of t is 0 at points pi, half, and 3 pi half. So the cotangent of p of t is equal to 0 at pi, half, and at 3 pi half. So we have information. We know at what point the cotangent, the curve, is going to cross the x-axis. We'll have the x-intercepts. So basically, pi half, comma 0, and 3 pi half, comma 0, are two x-intercepts for the cotangent. We also know the vertical asymptotes for the cotangent, and we also know the period for the cotangent. We will focus on one of the periods, pi. Let's go up here, and the period pi for the cotangent will be right here. Let's focus on this interval only. What is the x-intercept here? Well, the x-intercept will be at pi half, 3 pi half, 5 pi half, 7 pi half, and so on. So for the interval that we want to focus, we have only one x-intercept. What does this mean? This means that the curve crosses the x-axis, the t-axis, the horizontal axis, at pi half, right here. This is going to be an x-intercept, and only this. We also know, as we said before, that before it reaches pi, the cotangent is going to be negative, while after it reaches pi, it's going to be positive. This will also give us the information about how the cotangent will look like. Okay, let's take a few points. Let's take 1 point, just 1 point right here. This point right here tells us that at pi 4, the cotangent, that is basically cosine divided by sine, is going to be the cotangent at pi 4. It's going to be equal to square root of 2 over 2 divided by square root of 2 over 2. And this is equal to 1. So we have also another point for the cotangent that is the p4, 1. Let's graph this point. p4, that is right here, 1, that is right here. That's a point. Let's see what happens at 3 pi 4s, that is right here. Well, again, the coordinates are going to be square root of 2 over 2, negative square root of 2 over 2 for the cosine, and square root of 2 over 2 for the y-axis, for the y-coordinate, so for the sine. So at this point right here, the cotangent is going to be negative 1. And this is the point 3 pi half, so right here, it's going to be negative 1. So we have basically 2 points for the cotangent, except of the pi half. We also know that the cotangent has a vertical asymptote at pi, and since it has already crossed the x-axis, it's not going to cross it back, so it's going to go vertically and try to approach the vertical line x equals to pi. Same thing on the top, where the cotangent right here now tries to go vertically and approach the x equals to 0. So as you can see, we have the curve of the cotangent at this point needs to go right here and reach the point here. We also know that the cotangent is a function that repeats itself. So this means that we have exactly the same type of functions, exactly the same type of shape as I move on, repeating throughout the domain. Now, this is the cotangent. That's the graph of the cotangent. And this is what you need to remember that the cotangent looks like. What I want you to also focus here is that let's try to remember how the tangent looks like. And I'm going to change color here in order to graph the tangent. The tangent is the reciprocal of the cotangent. So what does this mean? The tangent has a period of pi again, but is going to have vertical asymptotes where at the points where the cosine is equal to 0. And the cosine is equal to 0 at the points of pi half, 3 pi half, 5 pi half, and so on. So at these points right here, you will have the vertical asymptotes of the tangent. Also, we remember how the graph for the tangent is. The tangent graph goes exactly the other way of the cotangent. So it looks like this. Again, it goes asymptotically to its vertical asymptotes. And as you can see, both of them meet at the point of 3 pi halves right here. Three pi fourths actually. They meet here, and they would also meet here because this is another vertical asymptote for the tangent. And as you can see, they are going to meet. If I want to graph my tangent, will look like this. And almost right here. And this is the pi fourths. Now, why this happens? If you look at the pi fourth, what do I have? I have exactly the same, the cosine and the sine, and the cotangent and the tangent is going to be 1, because 1 is the reciprocal of 1. While right here, the cotangent is -1, and the reciprocal of -1 is again 1. So they are going to meet, if I want it to be correct, I should have been right here. So this is how the graph looks, and this is the relation of the two trigonometric functions, cotangent and tangent.